Okay.
All right, good afternoon, everyone. My name is Zach. I'm the project lead for UCI's BajaSAE team, and with me today.
Hi, my name is Pedro Luna. I am the powertrain sub-team lead.
I'm Luis Gomez. I'm the brakes and ergonomics lead.
And I'm BajaSAEracecar, and I'm the rear suspension team lead.
All right, so a little bit about our project. BajaSAE is an intercollegiate design competition hosted by the Society of Automotive Engineers. The yearly competition hosts 100 collegiate teams from across the world in designing and competing with a single-seat off-road vehicle to the competition specifications, at which point the competition then culminates in the 100-car, 4-hour wheel-to-wheel endurance race, which is strategically designed by the competition organizers to destroy your car. A bit about our goal. We intend to achieve a top 10 result at the upcoming competition in May in Gorman, California. We will be competing the first time in Gorman, I think, in over a year. Last year's competition was hosted in Oregon, so the travel times will be a lot more compacted this year for us. And onto the project requirements, we intend to reduce the vehicle weight from 413 pounds to approximately 380 pounds. That's the curb weight of the vehicle with all fluids and no driver in the car. And we also intend to reduce the vertical center of gravity by about 8 inches, in order to improve performance and reduce body roll of the vehicle in dynamic events. We also intend to verify all of our components with physical testing. Each subsystem has their own testing procedures outlined for the components that they manufacture. And we will, of course, be defining and documenting all those testing procedures so that we can present them in the design review at competition for points, of course. This is the breakdown of the team. We're currently organized into 5 key subsystems. I specifically oversee the chassis sub-team as well, as it integrates all other subsystems into its design. On to our milestones. As you can see here, we're moving along at quite a reasonable pace. We have the chassis fully manufactured, and we intend to have a running testable vehicle by the time we hit the design review in the coming weeks. This is the status of the chassis subsystem. The chassis has been fully manufactured. We intend to complete fully welding it in the coming days, and after which we will be conducting a torsional rigidity test. This test is designed to test the spring rate of the chassis in twist. It determines the amount of force required to deform the chassis by 1 degree from front to rear. Our torsional rigidity goal is 850 foot-pounds per degree, which is on par with previous year's chassis designs. But this year's chassis design saves about 15 pounds over previous years. On to the powertrain sub-team that will be presented by Pedro Luna.
So for powertrain, the current status is we have our gearbox design complete and our engine mount is currently fabricated and installed, as you can see in the picture there. The fuel system and gearbox mounting will be fabricated in the coming weeks.
Onto brakes and ergonomics.
So for brakes and ergonomics, this quarter we pretty much put together a pedal box. As you can see this picture on the left, it's been fully tack welded and it's been jigged in the chassis, making sure it's in the correct placement and comfortable placement for the driver. Our brake line system has also been assembled, so make sure that our hard line and flex line are the correct length so brake fluid can be appropriately distributed to all components of the brake system. You see in the top picture, our inboard brake design has been complete. The purpose of the inboard brake design in the rear is to help us reduce weight in the car. And then for ergonomics, the main thing we focused on this past quarter is getting the seat laid back to 15 degrees so it matches the chassis angle. So the increased layback, as proven by our driver, Ryan, is more comfortable than last year's.
And front suspension.
I'm going to represent for front suspension today. The main goal for front suspension is to maintain contact of the tires and the ground at all times so that the driver can maneuver the car better. Last week, the design has been finalized for front suspension. and all materials have been ordered. So next week we should start our manufacturing process. For rear suspension, the main goals were to not for rear suspension, the main goal was to keep the axle from binding. Last year it binded and popped out, and that was caused by too many loads on the axle and too much droop of the wheel downward. And so we also wanted to make sure the trailing arm doesn't bend, and it is now structurally more resistant to bending during rollovers. For both front and rear suspensions, the main shared goal this time is to ensure comfort of the driver, and that was achieved by keeping the natural frequencies of the suspension systems within 10% of each other. The rear would have higher natural frequencies so that when you go over bumps, you don't feel like hard jolts. And now I'm going to pass it on to Zach to talk about cost per foot.
All right, as you can see here, this is the breakdown of our team budget. It is actually $4,000 less than last quarter's presented budget. This is because we have decided to scrap last year's car for parts in order to cut costs. And due to that, we were able to save around $4,000. So much else to talk about? Do you have any questions?